a compound containing copper and chlorine, we have to know the charge of copper. Copper is a transition metal. It can have more than one possible charge. So to do this, we bring the subscript of each element up as a charge on the opposite element. So that 1 on the copper comes up on the chlorine as a minus. The 2 subscript on the chlorine comes up as a +2 on the copper. After we do this, we want to check the negative charge, make sure it is correct. And chlorine does form a -1 charge, so that is correct. That means our copper is correct. So our name is copper 2 chloride. And the 2 we write is Roman numerals inside parentheses. So to get the formula of calcium acetate, well, calcium we know is Ca. Acetate is a polyatomic anion. We have to know the formula of the polyatomic anion along with its charge. So that is C2H3O2 with a -1 charge. And the formula of it is this structure. So the calcium has a +2 charge. So we're going to take that -1, take the 1, put it on calcium. We don't write that. The 2 we want to put on our acetate. To do that, we need to put a parenthesis around the acetate. And then the subscript, so calcium acetate. To name CCl4, this is a covalent compound. So we're going to use prefixes to identify the number of each element present. Carbon has an implied 1, so we're just going to write carbon. Then Cl has subscript of 4. 4, the prefix is tetra. Chlorine we're going to change into a IDE suffix, chloride. So we're going to have tetrachloride. So the name is carbon tetrachloride. For HI, if that was a gas, liquid, or solid, we'd call that hydrogen iodide. But as an aqueous solution, it becomes an acid. And it's a binary acid containing only hydrogen and a nonmetal. So the binary acid convention means we're going to start off calling it hydro. And going right into the name of the nonmetal iodine, we're going to change the suffix, the ending of that, to an IC ending. So iodic. And that's going to be one word, hydroiodic. And then we're going to throw the word acid after it. To get the formula of acetic acid, it doesn't start with hydro, so it's not a binary acid. So it's a ternary oxyacid. So we're going to look for the polyatomic anion that it's made from. And the IC suffix means it comes from an ATE anion. So we're looking for the acetate anion. Well, the acetate anion is C2H3O2 with a -1 charge. So we're going to neutralize this charge with H+ to turn it into an acid. So we're just going to put the H+ in front of it, not combine it with this set H. These are non-acidic H's. So we're going to keep our new H separate. So H, C2H3O2. And in the compound, when we turn it into an acid, that negative charge in the oxygen gets replaced with our H